Hello, and welcome to the next part of our Elm Goose-Driven tutorial. And now we have some geese here. As you may see, I've changed our spiral renderer to a grid renderer. And also if we add rotation, it turns out to be something also nice. And today we are doing animation. That's it. Nothing very fancy. We'll just rotate things, I suppose. Unless something, I don't know. So where do we start? Seems we need time here in our renderer. And it could be just float, and we could just add it to the renderer and keep doing the same thing we did in the previous part, like adding these things here and there and passing them. Sounds boring, right? That's because we're doing it different way now. Seems we got several arguments which are actually combined together and represent the state of our renderer. So it needs time, textures, and transformation metrics like the current one. So it's probably the nice idea to join them in one argument and stop pretending like they're separate. We could have do it with a tuple of 3 items, but it's not that good. And it's time to create our model, to define our model, not create it. Let's not name it model, but render state. I don't know. Yeah, render state. Just so that we will see that this name can be anything. So it now will contain time, textures. This is the record type in Elm, which is the same as object in JavaScript or dictionary. Yeah, different dictionary a bit in Python and so on. But it's different also in the way that you cannot change it. You just can create another instance of it. But that's like with everything in Elm. So now our renderers accept the render state. We also need to change things here and there, but now it's for a long time. No, it's just model here. No, render state, I called it. State. And we replace both these arguments with the state. And here as well. And here as well. Again, like everything manually. Here as well. Sorry. The space here. And here as well. And here as well. And here as well. And here. And even here. Come on, the spaces. And here. But we'll never do that again because of what we did. Now it's for ages. The render, and also we don't forget this way that we have other renders. We don't use them a lot, but they are still there and can be used. And I hope that you will try to create your own experiments with them, because here I have not much time to do a lot of experiments, but the potential is serious. Okay, now we get to some problem we'll fix a bit later. And here as well. And here. And here. And finally, not finally, it was already finally. So what we do in this case, we just take metrics from the state. What we do in this case, same thing. Are not the same. Yeah, same thing. State metrics. And what we do here is take this state and pass the new metrics there. Sorry, metrics. Right, now we fix this one. In this case, almost the same. State. This is the what I write is this syntax. To update the field in the record with something new. And now it's not it's state metrics, and move it. That's right. And now we don't need those, and this is wrong because we need to put it here. this here is just the minus sign, so I'll copy paste and remove the minus sign. Image renderer, just state textures and state matrix transform. And here, oh, I forgot this one. State, again, state where matrix is the new matrix, which is translated, the original matrix translated, rotated and translated, and remove these arguments. I hope this is the last one, because we just we also take current state, but the matrix is now the local one, and here and here as well, but it's not just the local one, but also the translated local one. State, oh, maybe one moment please, since this function use only matrices, let's keep it the way it was. Oh, we need, yes, in this case we need to, sorry, I removed it, to replace the matrix with the local one, but not this case. And in this case we just take state a matrix let's remove these things, don't need them anymore, and they just confuse. So that should be it. There's something that the last thing, yes. Okay, let's do it that way, just to make it compile. It's very temporary. The time is 0. Textures are the textures we have. The matrix is transform init. Yes. Right? Yes. Now it compiles and it is the same as it was, but the code is different. So, I also want to, this will be the time from the start of the application, not the actual time in seconds, not the POSIX time or something. And we are grown-ups now, so we are moving out of the sandbox, and we change it to almost the application, but the element. And in this case, we need to provide, we want to provide subscriptions. And if you develop something in functional reactive programming, subscriptions are very similar to signals. They just produce the messages. So yeah, you can subscribe to the signal. They're just coming from the browser, and you actually can produce some on your own, but it's not the topic of this part. Sorry. So, and now our model is not only the textures, but this render state. And so we have to change. Let's keep it sub none. Our definition is wrong now because we've changed like the model, and we have to update everything here to match our update. So now let's move the initial model out of there. And now it's a function of flex, which we ignore. So therefore we have unit there, and it returns the render state, the first one, and something we call comment of messages, which is side effects of our program, but we will have none. And thanks to the elm-canvas package, we had none for this moment, since loading the texture is actually the side effect, but it got through us, and we were able to use the sandbox even still. Okay, so the first state will be time 0, textures are empty, ticked empty, and what we have there, matrix is transform init. And no comments to perform. Now we change it to init here, or draw canvas. Draw canvas now also accepts render state instead of just textures, and we name it state, and we just pass it here inside. Now to the update function, which is also different now, because now it accepts render state, the previous render state, and returns the new render state and the side effects to perform on the next update cycle, which we have none. So we do this. Again, it's a tuple, but since anything can be the expression, now we use the expression for that. So we could have just write state in here, and that would be a tuple, but we want to perform some logic with the first element of the tuple before returning it. In case the message is no op, we do nothing and return the previous state. But in case we got texture, we update the textures dictionary with the new one, textures, and that's it. And now the difference is in the subscriptions. It says that subscription sub none, but it should be model. Why add subscriptions? It should be subscriptions. Right. We got our program back again. Again, visually nothing changed, but a lot changed inside, because now we can track time. And for that we need to import browser events module as browser. I suppose it's just the name we'll use. And still we don't care about the last state of the model for now. And we just, browser on animation frame delta. Now it doesn't suggest. And now we need to provide a message which will be fired, the message which will be fired when we got new animation frame. And that's easy. We just add the new message here. It will be just float because it will be delta t, not the actual time, but the difference in milliseconds between, or seconds, I don't actually know, between the previous frame and the new one. And so we just say tick when we got the new frame, and that's almost it, because we also need to handle this message, and Elm tells us that we forgot to handle this message, and it will be delta time. And so we change our time value to the previous time plus delta. That's it. And so now we may use this value in, for example, that was kind of easy if we forget about that we had to change every renderer again, but last time everything else is kind of easy. The animation is easy in functional programming. So I have to prove it. Let's take our image renderer, take textures out of it, textures, change it back to textures, take metrics. Actually, why? No. Let's keep it the previous way. State metrics. We just do transform, rotate, or let's scale. But we need the value from 0 to 1 in this case because we don't want them to make them large. So let's take the sinus of time. State time. I haven't tried it. Of course, yes, I do understand what is happening. We just draw them over and over. And we need something looks like Zelgo text. Sorry, it just became creepy, and I should put an introduction that the images here could be creepy. One moment, please. Yes. Clearing canvas in the elm-canvas package is just one more renderable. I will just copy paste from another code. So this is clear. And we need to put it together with our renderer. I hope this is yes. Wow, that's it gets creepier and creepier. Okay, if we change both scales, it's too much. Seems so. But sine is supposed to produce values from 0 to 1. Or maybe, maybe there will be. Okay, let's divide it by some huge value. So yes, this will be, and here as well. It seems it's just transforming. Yes. Okay, they're all scale. Where have you gone? Let's make it 2000. Yes. Since we have no origin here, come back. It's probably going into -1. That's why they go for so a long time. Let's don't do scale anymore, and let's change it to rotation. I'm afraid that the rotation will also be, well, that was also fun. The rotation will also be applied not to the origin of the image, but the whole thing. Let's try. This is the problem with this, with combining those transformations, and I will leave this, solving this, to your homework, just because I also don't know what to do in this case. And yes, they are rotated both all together, but also if we make it slower, they are also rotating around their axis. How could it be? I don't know. But still, you see that we can use the time value in our animations. We can change colors for things on time. I think let's do some example with a tree renderer. I will do it and get back to you. Try to do it. I did different thing. Not the tree, but I got back our previous spiral renderer. It doesn't change a lot. And I realized that the problem could be that we used the new metrics on every cycle, because it renders on every cycle. And for grid render before, we passed the previous metrics, so we was adding to the previous one. We'll also try to fix this thing, but I just thought that this is kind of beautiful, the thing we got here. Also, we need somehow to change the origin point of the animation, because this doesn't help. This just makes them more condensed. But this is kind of beautiful. Yes. What if we make the 1,000 of them? Not that fast, but still works. Here it's just smooth. Okay, yeah. Sorry. So we again comment out this thing, the thing we don't need also, and get back to the grid once more and try to reset the metrics on every frame. Nothing has changed. Or was it? But I don't see the change. So no, it wasn't the problem. Let's try our tree renderer anyway, and maybe change not the transformations of the geese, but the something like color. I don't know how could we change the color of those. Okay. Look what I did instead of the tree render. The tree renderer works. It's okay. It needs some tuning, but still. So what it does, it takes several spirals. First, it prepares the items, of course. It takes 3 spirals and renders them in different states, and then it goes to the spiral renderer, which I also changed it a bit, just a bit. Where is it? Those two are new transforms, and this is the previous one. So yes, that's it. And what will happen if I scale it also as well? Scale, and also take time for that. The sinus of time. We have to do it for both axes. Crazy, still crazy, but we can control it by dividing, lowering the rate of animation. Good. Okay, I think that's enough of trying. What was it? Sorry. Okay. Okay. What if we make it faster than the other one? So you can do weird things now. You have your instruments And just imagine that, for example, you may subscribe to some JavaScript port, which sends, if you have some MIDI controller, sends some value inside the animation, so you can move it on your own. Maybe I'll try it in the next part. So that's it for now. I think we've done with the animation. Not done, of course, because there's a whole field of things to do. But I gave you the example of how it can be done. Thank you, and maybe to the next part.